现在我有冰淇淋，我很喜欢冰淇淋，冰淇淋，我很喜欢冰淇淋，冰淇淋，我很喜欢。
Three, two, one. Hi, my name is Chris Barch, and my partner for my physics project today is Yanaphat Wangarrayagul, and our topic for today is torque and angular momentum. So today I'll be explaining and teaching you guys about torque and angular momentum, while Yanaphat Wangarrayagul is going to be giving and doing the experiment and explaining it to you guys. So let's get started into it. So first, what is torque? Torque is a measure of the force that can cause an object to rotate about an axis. Just as force is what causes an object to accelerate in linear kinematics, torque is what causes an object to acquire angular acceleration. Torque is a vector quantity, which for torque also have a formula, as we can see over here. Okay, now after we understand torque, let's get into angular momentum. So angular momentum. In physics, angular momentum, sometimes called moments of momentum or rotational momentum, is the rotational analog of linear momentum, or the property of any rotating object given by moments of inertia times angular velocity. It is the property of a rotating body given by the products of the moments of the inertia and the angular velocity of the rotating objects. Now let's get into examples and application. So for torque examples, torque can be termed as a rotational force that can make any object move across its axis. Pivot of fulcrums. If we consider torque application in real life, the turning of the bicycle wheel or bolt twist, or the opening of the door by its hinge, and so on, are also torque, or examples of torque. So now let's get into applications of torque. Applications of torque. The most obvious examples of torque in action is the operations of crescent wrench losing a lug nut, and a close second is a playground seesaw. But torque is also crucial to the operating of gyroscopes for navigations and of various motors. Both internal combustions and electrical are also torque's application. Next, let's get into experiments introduction, which we won't have slide here. So in which for our experiment we are going to use torque and angular momentum to explain how Bill was able to not fall straight after letting go of it. So for example, you guys might want to try to imagine like a wheel in the air with a string holding one side, and we are gonna do some experiment that show how the wheel could float, or at least not fall straight into its normal position by gravity. Now I'll pass on to the experiment to Yanaphat Wangarrayagul.
Thank you very much, Chris Butch. So this experiment basically uses a bicycle wheel to demonstrate the directional force that a torque creates, and I will now send this to Yanaphat and Pilaphat in the afternoon.
Hello? So as we know, if we just let go of the wheel, the force of gravity will act on the bottom and it will drop down. However, if we add a twisting motion to it directly on our side and add angular momentum, if we just do it fast enough, the wheel won't drop down. This happens because we applied a twisting motion or torque to the wheel, making it retain its force and have This causes the wheel to have angular momentum, thus causing it to retain its original position because both forces, the gravity and the torque, is acting against each other. So that means the faster and the more power you put into each spin, the longer it will last and stay in position.
This causes the wheel to have a gyroscopic effect, which is the ability of the rotating body to maintain its steady direction of its axis of rotation.
This concludes our experiment. Thank you.